All right, algebra, time to check out some of our special products of binomials. This is where it starts getting fun. So you are going to learn some of the patterns today that you will be using all throughout Chapter 9 as we are factoring. So the first special product that we're going to look at today is binomial squares. So first, let's review using our FOIL method that we learned yesterday. So we're going to multiply the first, outer, inner, and last term. So if I multiply the first, that's going to be x times x, which is x squared. If I multiply the outer, that's going to be first and last. Here, my very outside edges, so x times a positive 3 is a positive 3x. My inside terms is a positive 3 times a positive x. And my last terms is a positive 3 times positive 3, which gives me plus 9. So now I can come through and clean up by combining my like terms and simplify this to x squared plus 6x plus 9. That's how we learned to multiply this and using our FOIL method. So today we are going to look at what we started with, and we are going to begin recognizing this as a pattern that we call binomial squares. So remember bi meaning two, and we're looking at two terms in an expression, and we are going to take a binomial and square it. So we're going to multiply it by itself. So we're going to become very familiar with this pattern right here. So when we are factoring and multiplying, we can work easily and quickly with simplifying these and changing them back and forth. So my rule is that I'm going to take the first term and I'm going to square it. So my first term is x, so I'm going to square it. That becomes x squared. Plus, to that, I'm going to add double the product of the outer terms. So when I multiplied my outer terms, I got 3x. If I double that, that becomes 6x. Plus, to that, I'm going to add the square of the last terms. My last term, in both cases, are 3 because I have the same binomial, and so I square 3 and I get 9. That's my shortcut without having to actually go through and FOIL this. When I recognize that this is a binomial square, then I can just square my first term, double the product of the outer terms, and square my last term. And then I have simplified my multiplication problem. Let's look at another example and see how this works now that you've seen it once. So I have, again, a binomial square. I have the same binomial, x plus 6, multiplied by itself. So I'm squaring it. So I'm going to use my shortcut where I'm going to square the first term. My first term is x. If I square it, I get x squared. Plus, I'm going to double the product of the outer terms. X times 6 is 6x. I double that to get 12x. Plus, now I'm going to add the square of the last terms. My last term is 6. If I square it, I get 36. So using my rule, I have a shortcut to simplify. The next special case we're going to look at is called a difference of two squares. So think about the names to help you remember what they mean. Difference meaning subtraction, and I'm subtracting two squares, one from the other. So it's going to look like this in factored form. I have x plus 5 times the quantity x minus 5. So here's my rule, here's my shortcut. I'm going to square the first term. My first term is x, so I square it and it becomes x squared. Notice that that term is the same in both binomials here. Then from this, I'm going to subtract the square of the last term. I'm going to subtract the square of 5, which is 25, and now I've simplified. But let's use FOIL to double check our answer. We can always fall back on FOIL, multiplying the first, outer, inner, and last terms. in case we forget any of these shortcuts. So let's go ahead and FOIL. Our first terms are x times x, which gives us x squared. Our outer terms are x and negative 5, which gives us a negative 5x. Our inside terms are positive 5 and positive x, which gives us plus 5x. And my last terms, positive 5 times a negative 5 gives me negative 25. Now if I clean up a little bit and combine like terms, I have a negative 5x and a positive 5x. Those are additive inverse, so they cancel to 0. And I can simplify this to x squared minus 25. You will notice how much quicker it is to use our difference of two squares rule and our shortcut. And we were able to do that in one quick step. We don't have to combine like terms and we don't have to FOIL it out. You can see that once we have multiplied this out, it's very easy to see the difference of two squares. Remember, difference meaning subtraction. Two squares, x squared and 25 are both example of square numbers. So that's the difference or the subtraction of two squares. So that's how you can remember this. But when it is factored, it's going to look like this. Same two terms in the binomial, same first term, same second term, but opposite signs. Let's try one more like this. So I have x minus 4 times x plus 4. I'm looking at this and I'm thinking, okay, I could FOIL, but is there a shortcut? So is this a binomial square or a difference of two squares? Because I see the different signs, I remember this is difference of two squares, so I'm going to square the first term, which gives me x squared. Then I'm going to subtract the square of the last terms. 4 squared is 16, so I get x squared minus 16. Let's put this into practice with a few more that may look different. So we're going to multiply these binomials by using the rules for special products. So on this first one, I have x plus 7 times the quantity x minus 7. Same terms in each of the binomials, but different signs, so I know that this is the difference of two squares. So I'm going to take the first term and I'm going to square it. It gives me x squared. And because I need the difference of two squares, I'm going to subtract, and I'm going to square my last term. 7 squared is 49. On number 4, I have x minus 8, the whole quantity squared. So really think about this. This means x minus 8 times x minus 8. Let's take a quick moment here to remember that we cannot distribute exponents across an addition or subtraction expression. This does not equal x squared minus 64, which we'll see as we simplify this. What this means is that this binomial, x minus 8, is a factor twice. So I multiplied this by itself. So I have x minus 8 times x minus 8. And if we remember our rule for this, I'm going to square the first term, which gives me x squared. Then to that, I'm going to double the product of my outer terms. So I have a negative 8 times x, which is negative 8x, and if I double it, that's going to be negative 16x. So I'm going to go ahead and instead of saying plus a negative, I'm going to simplify my signs to minus 16x. And now to that, I'm going to add the square of my last term. 8 squared is 64. So you can see, and you will begin to remember as you practice this, that binomial squares, when you've multiplied it out, you end up with a trinomial answer, 3 terms in our polynomial. Very different than x squared minus 64. So remember, do not ever distribute an exponent across an addition or subtraction expression. All right, a few more examples. These get a little more complex. Same idea, we just have to keep track of exponents. So I see that I have two binomials that I'm multiplying here. 5x minus 7y times 5x plus 7y. These are the same terms, but opposite signs. One subtraction, one is addition. So I remember that this is going to be the difference of two squares. So I'm going to take my first term and square it. 5 times 5 is 25. X times x is x squared. And I'm going to subtract from that the square of my last terms. So 7y times 7y gives me 49y squared. Let's check out number 6. On number 6, I have 2a squared plus 3b times 2a squared plus 3b. So this is a binomial square because I'm taking the same binomial and multiplying it by itself. Remember, this is the one that gives you a trinomial answer, so I should get 3 terms in my multiplied version. So I'm going to take my first term and I'm going to square it. 2 squared is 4. A squared to the second power is a to the fourth. For my middle term now, I'm going to add to that double the product of my outer terms. So I'm going to do 2a squared times 3b, which gives me 6a squared b, and I'm going to double it to 12a squared b. That's my outer terms, the product, doubled. And for my last term, I'm going to add my last term squared. So 3b squared becomes 9b squared. So I have a trinomial answer, 3 terms in my answer. And finally, let's take a look at what this looks like when we are multiplying functions. If I need to perform the indicated operation using the functions f of x equals 3x plus a half and g of x equals 3x minus a half, on this first one, I'm looking for the product of these two, f of x times g of x. So I'm just going to substitute because I know what f of x equals. It equals 3x plus a half. And I'm going to multiply that by g of x, which is 3x minus a half. So as I write this out, now I can see, and I'm going to slide this over. Now I can see that what I have is a special product pattern here. So I have a difference of two squares. I have the same terms. My first terms are 3x. My last terms are 0.5, but I have opposite signs. So that's going to be my difference of two squares pattern, which says I take my first term and I square it. 3x squared, or 3x times 3x gives me 9x squared. And then I'm going to subtract, because this is difference of two squares, 1/2 squared. So I'm going to take 0.5 times 0.5. And my pen is no longer working. There we go. So I get 9x squared minus 0.25. For part B, this time I'm going to take f of x and I'm going to square that entire function. So I'm going to substitute this binomial. This is what f of x equals. I'm going to substitute this in. And I'm going to square it. So now I can see that I'm doing a binomial square. I'm taking this binomial and squaring it. I'm multiplying it by itself. So my rule says I take my first term and square it, 3x, and if I square the whole product, I'm going to get 9x squared. Then I'm going to take the product of my outer terms. So if you need to rewrite this so that it looks like the product of two binomials, if that helps you, you can do that, so that you can see your outer terms. So that's going to be 3x times 0.5. And so when I do 3x times 0.5, I'm going to get 1.5x, and then I need to double it. which gets me right back to 3x.